So for the sum of a finite geometric sequence, the formula is S sub n equals a sub 1 times the quantity of 1 minus r to the nth power all over 1 minus r. If r is not equal to 1, then it is possible to get the sum. But if r is equal to 1, then it is not possible for us to get the sum of the geometric sequence. So for the sum of an infinite geometric sequence, the formula is S sub infinity equals a sub 1 all over 1 minus r. If r is less than 1 but greater than negative 1, then it is possible to get the sum. But if r is greater than or equal to 1, or r is less than or equal to negative 1, then it is not possible for us to get the sum of an infinite geometric sequence. Example: find the sum of the first 8 terms of geometric sequence 1, 2, 4, 8, 16, and so on. So again, we need to identify first all the given values. So n is equal to 8. That is the total number of terms. And the first term, or a sub 1, is equal to 1. And r, or the common ratio, is equal to 2. That is a sub 2, which is 2, divided by 1, which is a sub 1, is equal to 2. So to find the sum of the first 8 terms of a geometric sequence, we need to use the formula S sub n equals a sub 1 times the quantity of 1 minus r to the nth power all over 1 minus r. So we have here all the given values. So next, we need to substitute all the given values to our formula. So that is S sub 8 is equal to 1, which is a sub 1, times the quantity of 1 minus 2, which is the value of the common ratio, or r, raised to the power of 8, which is the value of n, all over 1 minus 2, which is the value of r. So simplify further, that is equal to 1 times the quantity of 1 minus 256. So where did we get 256? That is the value of 2 to the 8th power. So that is 256. So 1 times the quantity of 1 minus 256 divided by negative 1 is equal to 1 times the quantity of negative 255. So how did we get negative 255? That is the difference between 1 minus 256. So 1 times negative 255 is negative 255. Divided by negative 1 is equal to positive 255. So the sum of the first 8 terms of geometric sequence 1, 2, 4, 8, 16, and so on is 255. Or S sub 8 is equal to 255. Another example, find the sum of the first 7 terms of geometric sequence 27, 9, 3, and so on. So again, we need to identify first all the given values. So for n is equal to 7, or the total number of terms. And the first term, or a sub 1, is equal to 27. And r, which is the common ratio, is equal to 1/3. How did we get 1/3? That is 9, which is a sub 2, divided by 27, which is a sub 1. And that is 1/3. So to find the sum of the first 7 terms of this particular sequence, we need to use the formula for finite geometric sequence, since the given sequence is a finite. So substitute all the given values to our formula. S sub 7 is equal to 27, which is a sub 1, times the quantity of 1 minus 1/3 quantity of 1/3 to the 7th power. 1/3 is the value of r, and 7 is the value of n, all over 1 minus 1/3. 1/3 is the value of r. And s sub 7 is equal to 27 times the quantity of 1 minus 1 over 2,187. We get this 1 over 2,187 by evaluating negative quantity of 1/3 to the 7th power. Next, s sub 7 is equal to 27 times 2,186 over 2,187 all over 2/3. So how did we get 2,186 over 2,187? So that is by simplifying 1 minus 1 over 2,187. And that is the result, 2,186 over 2,187. So S sub 7 is equal to 2,186 over 81 all over 2/3. So how did we get 2,186 over 81? So that is by simplifying 27 times 2,186 over 2,187. 2,187 divided by 27 is 81. So S sub 7 is equal to 2,186 over 81 times 3 halves. So how did we get 3 halves? So since this is division, so we need to get the reciprocal of 2/3, which is our denominator. So the reciprocal of 2/3 is 3 halves. So 2,186 over 81 times 3 halves. And the result is 1,093 over 27. And that is the sum of the first 7 terms of the geometric sequence, or S sub 7 is equal to 1,093 over 27. Another example, find the sum of this infinite geometric sequence. So since it is an infinite geometric sequence, we need to use the formula for the sum of infinite geometric sequence. So that is S sub infinity equals A sub 1 all over 1 minus r. So first, we need to identify first all the given values. So n is equal to infinity, and the first term is equal to 3/4, and r, or the common ratio, is equal to 1/2. That is 3 over 8 divided by 3/4. So next, we need to substitute all the given values to our formula. So S sub infinity is equal to 3/4 all over 1 minus 1/2. And S sub infinity is equal to 3/4 times 2 over 1. So where did we get this? So 1 minus 1/2 is 1/2. So since this is a quotient, this is division, and 1/2 here is our denominator, so we need to get the reciprocal of 1/2, and that is 2 over 1, or simply write 2. So S sub infinity equals 3/4 times 2 over 1, or 2. S sub infinity is equal to 6/4, and 6/4 is equal to 3 halves. So S sub infinity is equal to 3 halves. So that is the sum of our infinite geometric sequence. So we have here now the following formulas that we need to memorize. So to find the nth term of a geometric sequence, we have a sub n equals a sub 1 times r raised to the power of n minus 1. And to find the sum of a finite geometric sequence, we have s sub n equals a sub 1 times the quantity of 1 minus r to the nth power all over 1 minus r. And to find the sum of an infinite geometric sequence, s sub infinity is equal to a sub 1 all over 1 minus r. So that's all for today, and thank you for listening. Have a good day.